Thursday, the 25th of July 2024, direct from the 17th Australian Space Forum here at the Adelaide Convention Centre. These are the science and space headlines we're following on Talkin Science. Artemis 2's core stage on the barge, heading to the Cape. An intermediate black hole found in our neighbourhood. And deserved recognition, the women of Apollo get a building named in their honour.
21 years online. From Star Trek to science and space, and we're not stopping. This is Talkin Science.
A research team in New Zealand has revealed a lack of environmental sustainability or even compliance in the burgeoning space sector compared to economic growth. The team reckons that government incentives could help drive change in the burgeoning sector. Meanwhile, the core stage of the Space Launch System has rolled out at a NASA manufacturing facility in New Orleans this week, on the barge now heading to the Cape. Technicians used highly specialised transporters to get the SLS rocket stage rolling on the 55th anniversary of the launch of Apollo 11, with the move marking the first time since the Apollo program that a fully assembled moon rocket stage for a crewed mission has hit the pavement outside the facility. Engineers manoeuvred the giant core stage from inside NASA's Michoud Assembly Facility in New Orleans to the agency's Pegasus barge. That barge will ferry the stage more than 900 miles down the Mississippi River to NASA's Kennedy Space Center in Florida, where engineers will prepare it in the vehicle assembly building for attachment to other rocket and Orion spacecraft elements ahead of Artemis 2 in September next year. A neutron star close to Earth is spinning as fast as a blender. Known as a millisecond pulsar, it's rotating around 174 times per second, but much of its characteristics have remained a mystery. Now, thanks to almost 30 years of observations from Muriang, we know its mass, and that's the key to knowing so much more. In a series of 3 papers accepted for publication in Astrophysical Journal Letters, a global group of scientists describe how Muriang, together with NISA, the Neutron Star Interior Composition Explorer, which is NASA's X-ray telescope on the International Space Station, have accurately measured the mass and radius of this nearby neutron star. And while particle accelerators, such as the Large Hadron Collider, are also used to study matter at its extremes, those experiments fail to predict the behaviour of the unique matter in the cores of neutron stars. This means neutron stars are some of the best laboratories for physics, and measuring their masses and sizes is a way to get new insights into fundamental nuclear physics. A massive black hole, about 20,000 times the size of our Sun, has been confirmed as the closest to our solar system by an international study involving University of Queensland researchers. For more, UQ's Associate Professor Holger Baumgart is beaming in. Professor, welcome. The study involved analysing and cataloguing 1.4 million stars in the Omega Centauri cluster.
Yes, that is correct. So that was done by my colleagues in Heidelberg, who had a look at really many images which were taken by the Hubble Space Telescope over the last 20 years.
It's been a 20-year mission of astronomers to prove this black hole's existence, and after analysing those 500 Hubble Space Telescope images, you and the team found it.
I mean, that has really been a long time in the making. Finding an intermediate mass black hole, I mean, they were predicted to exist already 50 years ago. And I mean, since about 25 years, astronomers have also begun looking for them in earnest. But I mean, so far it was really a tough story, because I mean, they were just not able to find any convincing case for an intermediate mass black hole in any globular cluster or dwarf galaxy.
Well, can you talk us through the theory behind the intermediate mass black holes?
Yeah, okay. I mean, so the problem is, I mean, we know already of black holes, but so far they have basically become in 2 weight classes. So, I mean, you have these so-called stellar mass black holes. I mean, these are black holes which form from massive stars. So probably any star more massive than 20 solar masses will turn into a black hole at the end of its life. So, I mean, these stellar mass black holes, they have masses between 20 up to 50, 80 solar masses. And then on the other hand, you have these so-called supermassive black holes. I mean, these supermassive black holes, so they are found in the centers of galaxies, and they have masses of about 1 million or even 1 billion times the mass of our sun. And the problem was, so in between these two extremes, I mean, no black hole has been known so far.
Was the theory that there had to be something between stellar mass black holes and supermassive ones?
Yeah, okay. I mean, that was not clear, really. What was really not known was how these supermassive black holes actually formed. So, I mean, there are different theories. So some say maybe they already formed with the masses that we see nowadays. So, for example, either in the Big Bang, the space just collapsed into these black holes and formed very massive ones, or maybe you had something which are called supermassive stars, so really stars of 100,000 solar masses, which also collapse into black holes. But they are purely hypothetical. So, I mean, there's one possibility is these supermassive black holes, they form almost in one go directly. But then there's also the alternative theory that maybe they grow out of stellar mass black holes so slowly over time. And I mean, especially in that second case, I mean, there you might really expect, okay, maybe then there should also be a few intermediate mass black holes existing in the universe. These are then black holes which grew, but just didn't make it into the supermassive regime.
The University of Queensland's Professor Holger Baumgart. Research now shifts to finding more of this class of black hole, how it relates to other massive black holes and where others might exist. NASA's Johnson Space Center in Houston has recognised legendary human computer Dorothy Vaughan and the women of Apollo with activities marking their achievements, including a renaming and ribbon-cutting ceremony of the centre's Building 12 last Friday, which just happened to be the eve of the 55th anniversary of the Apollo 11 moon landing. Dorothy Vaughan came to the Langley Memorial Aeronautical Laboratory in 1943 during the height of the Second World War, leaving her position as the math teacher at Robert Russa Moton High School in Farmville, Virginia, to take what she believed would be a temporary war job. 2 years after President Roosevelt signed Executive Order 8802 into law, prohibiting racial, religious and ethnic discrimination in the country's defence industry, the laboratory began hiring black women to meet the skyrocketing demand for processing aeronautical research data. Urgency and 24-hour shifts prevailed, as did Jim Crow laws, which required newly hired coloured mathematicians to work separately from their white female counterparts. Dorothy Vaughan was assigned to the segregated West Area Computing Unit, an all-black group of female mathematicians who were originally required to use separate dining and bathroom facilities. Over time, both individually and as a group, the West computers distinguished themselves with contributions to virtually every area of research at Langley. She helmed the team for nearly a decade before the NACA transitioned to NASA in 1958, when the West Computing Office was abolished. But the women joined the new Analysis and Computation Division, a racially and gender integrated group on the frontier of electronic computing. Vaughan retired from NASA in 1971 and sought but never received another management position at Langley. The NASA press release notes Vaughan's personal commitment and determination during the Apollo missions. She was a steadfast advocate for the women who worked as human computers and for all the individuals under her leadership. Well, in bad news for intergalactic surfers, international scientists are telling us that the seas on Saturn's largest moon, Titan, may be too small for surfing. The waves are probably only a few millimetres high, and there's plenty of rips to look out for. The scientists analysed data from the Cassini spacecraft, which collected radar observations between 2014 and 2016, finding that the methane and ethane-rich seas of Titan are mostly completely flat, but there's evidence of those small surface waves with the tidal currents the team detected caused by methane-rich rivers flowing into ethane-rich seas, they say. US and Italian researchers have found evidence of potentially accessible underground cave networks on the moon that could offer shelter to future crewed missions to the lunar surface. They say that over 200 pits have been found on the surface, with many having been created by cave-ins from lava flows beneath the surface. One of these pits, known as the Mare Tranquillitatis pit, has a radius of around 100 metres, and the researchers say their simulations, based on radar images, suggest the potential for a tunnel located between 130 and 170 metres deep, between 30 and 80 metres long, and with the width of around 45 metres. The authors suggest that volcanic tubes or conduits could be a common feature under the lunar plains, and that the Mare Tranquilitas pit and its conduit could be a promising site for a potential lunar base. The methodology presented could also be a viable option for assessing and characterising other lunar pits to identify additional conduits. Well, SmartSat CRC yesterday here at the conference announced the first 4 jointly funded research projects as part of the Australia-New Zealand Collaborative Space Program. Commencing in August 2024, the first 4 initial projects include research into monitoring methane emissions, enhancing real-time monitoring of greenhouse gases, managing free space optical communication nodes across Australia and New Zealand, improving the tracking of space objects, and developing a joint Australia-New Zealand concept for maritime domain awareness. For more, Chief Research Officer at SmartSat CRC, Dr. Carl Schubert, joined me a little earlier at the SmartSat booth here at the conference.
And we also have an open call that just went out today. It's an open call. We'll be funding another 4 projects under that call. And again, we're looking for New Zealand and Australian collaborative teams to come together, propose a particular project that's maybe driving some new analytics or some new technology to utilize Earth observation data. Those 4 calls, all of these projects are the starting of what we hope is a much bigger program and a much bigger collaboration between the 2 nations, ultimately to utilize space technologies. So we're just funding these scoping studies to then hopefully fund much larger projects that will be a follow-on or a phase 2 from this.
There's been a need for all of this data in land use and feedlot management and all this kind of agricultural purposes for it, stuff that we haven't really had proprietary machines for. And now we're getting to this point with SmartSat and these developments to be able to do all of this and bring everything in-house and have that sovereign capability.
That's exactly right. And right now we are, as our 2 nations, are fairly dependent on international consortia and allies when it comes to using their space assets. So we use existing satellites up there and utilize their data. And we're building the smarts in the data analytics to turn that into the information so we can actually use it. We are, though, starting to now break new ground into actually putting our own spacecraft up there. So MethaneSat is a great initiative that New Zealand government has got behind, and they're a contributing funder of that mission, and now they get to utilise it. In Australia, we have our own CubeSat, Canyini. That's a South Australian government-funded CubeSat. We have a payload on that, so SmartSat is responsible for the hyperspectral imager on that spacecraft, and we'll be using that for Earth observation purposes and applying it to land use and management. We're going to be doing some really great projects with that directly support programs within the South Australian government, our stakeholder in that project.
Well, Dr. Carl and I are going to go in depth on a Talkin Science interview about these first 4 research projects that have been funded, the call out for more, but also what SmartSat is doing generally with sovereign information capability, capturing our own information for our own use, particularly in agriculture. It's a big industry that can use a lot of space-based data acquisition. So look out for that one on the next Talkin Science interview. Right now, though, that is a wrap on the 17th Australian Space Conference, presented by the Dr. Andy Thomas Space Foundation here at the Adelaide Convention Centre. A huge thanks to the Dr. Andy Thomas Space Foundation for having us down with those press passes. Got to love them. A quick mention for Trekzone's socials and membership. Membership is available. Get first play, get early access and first play to all of our podcasts. Head to thetrek.zone/subscribe. And also on Facebook, Instagram, TikTok, X as well. The social medias, wherever you are, we're there. Search for Trekzone Media for now. This is Talkin Science for the 25th of July, 2024.